Okay, hello again. This is chapter 16 and we're now talking about electrolysis. Now, what is electrolysis? Do you have an idea what's electrolysis? You should realize that electrolysis is the breakdown of a substance such as an ionic compound, and this ionic compound has to be molten or aqueous solution. Do you know what's molten? Molten means it has to be heated until it melts, or dissolved in water, so in aqueous solution, by the passage of electricity. So basically it's the breakdown of a substance using electric current. This substance is usually an ionic compound so that it can conduct electricity. So electrolysis is the breakdown of an ionic compound, molten or in aqueous solution, by the passage of electricity. So basically what we have is we're going to have something like a beaker or some sort of container, and we're going to put an electrolyte in it. Now, what is the electrolyte? Electrolyte is a molten or aqueous solution that can conduct electricity. So the electrolyte is a solution that conducts electricity. Anything that's liquid that can conduct electricity is called an electrolyte. So that is the liquid that I have in there. And in order to conduct electricity as a liquid, it must have positive and negative ions. Now, the positive ions and negative ions have to be free to move in the solution. So this cannot be a solid. If the electrolyte is a solid, the positive and negative ions will not be able to move, so this will not conduct electricity. So the electrolyte is a solution or molten that has its positive and negative ions free to move so that it can conduct electricity. Okay, now, inside this electrolyte, I'm going to put two rods, which we call anode and cathode. These rods are what we call electrodes. An electrode is a rod that allows electric current to pass through. So it has to be made of a substance that conducts electricity. Now, what conducts electricity? Either graphite, and if you remember what we said about graphite previously, we said graphite is made up of carbon, so it is a non-metal, and it has free electrons, so it is the only non-metal that conducts electricity. So these electrodes usually are made of graphite, mainly because it conducts electricity and the fact that it is inert, that means it will not react with anything, and the fact that it is cheaper than any other substance. Now, if it is not graphite, it could be a metal, and this metal would either be platinum, but the problem with platinum is it is too expensive, or some other metal like copper or silver and so on. So that's the electrode. So the electrodes are two rods that are placed inside the electrolyte. Now, these rods will be connected to the two ends of a battery. Can you see the battery? Any battery will have a positive end and a negative end. So these two rods, one of them will be connected to the positive end of the battery. That could be through a light bulb. The presence of the light bulb is just to show us whether electricity is passing through or not. If electric current is passing through, of course the light bulb will go on. If there is something wrong and there is no conduction of electricity, then the light bulb will not go on. So that is just the function of the light bulb, to indicate that electricity is passing through. So one end of the one of the electrodes is attached to the positive end of the battery, and the other electrode is attached to the negative end of the battery. Now they are attached by what? Of course they are attached by electric wires. An electric wire is usually made of copper, and copper is a metal, and metals do what? Metals conduct electricity. And if we say why metals conduct electricity, because they have free moving electrons. So in that wire you have electrons, and electrons are negatively charged. A negative charge on the electron will be attracted to the positive end of the battery. So basically that rod that is attached to the positive end of the battery, electrons are moving towards the battery, and that means they are being pulled away from that electrode, and that means that electrode is lacking electrons, and that means that electrode will be positively charged. Do we understand that? So the electrode attached to the positive end of the battery, electrons are moving from it to the positive end of the battery, because electrons are negatively charged, attract to the positive end of the battery. Now that means that I'm pulling electrons away from that electrode. That electrode lacks or has less electrons. That means it is positively charged. Now, if it is positively charged, which of the ions in the electrolyte will be attracted to it? If the electrode is positively charged, the negative ions will be attracted towards it. Now, the negative ions are called anions, and that is why we call that electrode the anode. Can you see where the anode is? So the anode is basically the electrode that is attached to the positive end of the battery. So it itself is positive, and it attracts the negative ions to it. So the negative ions are anions, and we call the electrode anode. On the other end, there is another rod. That rod is attached to the negative end of the battery. Now, the electrons in the wire will be repelled away from the negative end of the battery, and that means the electrons will move from the battery to that electrode. That means the electrode will have a lot of electrons, and that is why it is negatively charged. Now, since it is now negatively charged, it will attract which ions? It will attract the positive ions in the electrolyte. The positive ions are called cations, so that electrode is called cathode. Are we okay with this? Okay, so that is the basic setup of everything we're going to be talking about in electrolysis. Now, let's do a simple experiment to distinguish between electrolytes and non-electrolytes. Do you remember what are electrolytes? We said, what are electrolytes? Electrolytes are liquids that conduct electricity. A non-electrolyte will be a liquid that does not, or a substance that does not conduct electricity. So what do we do here? We set up this. So we set up the circuit as shown. The electrodes attached to the battery with a light bulb inside a liquid that conducts electricity, which we should call electrolyte. And we're going to put different liquids in the beaker. So first of all, or different substances in the beaker. So first of all, we're going to put solid sodium chloride in the beaker. You should realize that if the substance in the beaker is a solid ionic compound, the solid ionic compound does not conduct electricity. Do you remember when we talked about ionic compounds? We said ionic compounds will conduct electricity only when molten or in solution, because I want the positive and negative ions to be able to move or to be free to move. So if I put solid sodium chloride in that beaker and I put the anode and the cathode in the solid sodium chloride, the sodium chloride will not conduct electricity. If we say why, because the positive and negative ions are not free to move. How do I know that it does not conduct electricity? The lamp will not light up. Okay, what if I change what's in the beaker and I dissolve the sodium chloride in water? So now I have a solution of sodium chloride. We said when the ionic compound is in solution, the positive and negative ions will be free to move, and that means the bulb will light up. That means that that solution conducts electricity, and that means it is an electrolyte. What if I replace the solution with a solution of something that's not ionic? Remember that sodium chloride was an ionic substance that has positive and negative ions. So when I dissolved it in water, it conducted electricity. But if I put a solution of something that's not ionic, like glucose, glucose is not an ionic substance. It does not have positive and negative ions. So whether it's solution or whether it's a solid or whatever, the lamp does not light up. Why? It has no positive and negative ions. Do we understand this? Okay, let's try a question. So this is a possible question that you could have. This apparatus is used to test whether magnesium, solid magnesium chloride, and an aqueous solution of magnesium chloride conducts electricity. So he has three things. He has magnesium, solid magnesium chloride, aqueous magnesium chloride. Okay, now magnesium conducts electricity. He found that magnesium conducts electricity. Aqueous solution of magnesium chloride conducts electricity, but the solid does not. And he's saying, explain these results with reference to the type of particles. So, why would magnesium conduct electricity? Remember, what is magnesium? Magnesium is a metal. Metals have what? Metals have, remember when we're talking about the structure of metals, they have regular rows of positive ions surrounded with a sea of delocalized electrons. And these delocalized electrons are free to move, and that is why magnesium as a metal will conduct electricity. Now, the solid and the aqueous of magnesium chloride, they both have positive and negative ions. Magnesium chloride is an ionic compound. Both will have positive and negative ions. But in the solid, will the positive and negative ions be able to move? No, and that is why it does not conduct electricity. But when it is dissolved in water, so it becomes an aqueous solution. Remember, aqueous solution means dissolved in water. Now, when we dissolve the magnesium chloride in water, we said the positive and negative ions will be able to move, so it will conduct electricity. So what you're supposed to explain, and this, remember, this has 6 marks. The magnesium has free moving delocalized electrons. So it is a metal, it has delocalized electrons that are free to move. These are 2 marks. Okay? Now, as a solid, we said it does not conduct electricity. This is because what? First of all, what does it have? Does it have electrons? It doesn't have electrons. It has positive and negative ions. And the ions are not free to move when it's a solid, because remember that ionic compounds as a solid have a crystal lattice, so the ions are fixed in the crystal lattice, or the ions are not free to move in this lattice. Now, as an aqueous solution, we said the ions will be free to move, so it has free moving ions that will allow electricity to pass through. Okay, so the rest of the chapter is based on a specific thing. They will give you a substance, and they will tell you we're doing electrolysis of this substance, what would happen at the anode, the positive, and what would happen at the cathode, which is the negative. Do you remember this? The positive rod is called anode. The negative end, the negative rod, is called the cathode. And we said the positive rod, which kind of ions will go to the positive? The negative ions go to the positive. Which kind of ions go to the negative? The positive ions. Remember in physics you had opposites attract. So, when we are talking about the anode is the positive electrode. Now, which ion goes to it? The chloride ions. Now, the chloride ions go to the positive to do what? They go to the positive in order to give their extra electrons to this positively charged electrode. So what happens at the positive electrode is the negative ions gives electrons or loses electrons. And when it loses electrons, it becomes atoms. Now, something like chlorine is diatomic. Do you remember what diatomic means? That the molecule has 2 atoms. So I cannot write just Cl. It has to be Cl2. Now, if it is Cl2, that means I need to balance the equation and put a 2 in front of the Cl minus. And if I have 2 Cl minuses, that means I have 2 negatives before the arrow. I need to put 2 in front of the electron to have 2 negatives after the arrow. Can you see how I balanced? This is what we call an ionic equation that's happening at the anode. So when he says write the ionic equation that occurs at the anode, you write this equation, 2Cl minus to give Cl2 plus 2 electrons. Now, there are 2 things that he will ask you. He will either ask you what is, or name the substance formed at the anode, or what is observed at the anode. Now, in our case here, what is the substance formed at the anode? It's chlorine. Now, that means, what will I observe? What will I see? Do you remember what is the color of chlorine gas? You should remember that chlorine gas is a green gas. So if he says what is observed, it is bubbles of green gas. Do we understand this? So that is what happens at the anode. Remember that always at the anode, the positive, a negative ion will give electrons. Now, loss of electrons is called what? Do you remember we did a chapter on oxidation reduction? What is loss of electrons? Was that oxidation or reduction? Loss of electrons is oxidation. So what happens at the anode is always oxidation. Oxidation means the negative ions lose electrons. Now let's go to the other rod. The other rod is connected to the negative end of the battery, so it is a negative electrode. Which ions will be attracted to it? The sodium ions, because they are positive. Now the sodium ions will go to the cathode and do what? Positive ions will go to the cathode and take electrons, always. They will gain electrons. And if you remember, gain of electrons is called reduction. So what happens at the cathode is reduction. Now when the positive ion gains electrons, it becomes atoms. In this case, sodium is not diatomic, so we just write sodium Na. And that means that what is happening at the cathode is I am forming sodium metal. Remember that this is a electrolysis of molten sodium chloride. Remember that we said sodium chloride is an ionic compound. If I'm doing electrolysis, it either has to be dissolved in water or it has to be molten. So we are talking now about electrolysis of molten sodium chloride. Now when he asks me anything about this, the first thing I thought about was the molten sodium chloride had which ions? It had sodium as a positive and chloride as a negative. If you don't remember which one is positive and which one is negative, usually the first one is the positive ion and the second one is the negative ion. So Na is the positive and the Cl is the negative. Now the negative goes to the positive electrode and loses electrons. The positive will go to the negative electrode and gain electrons. So this is molten sodium chloride. That means I heated the sodium chloride until it melted. And that means that this is happening at a very high temperature. And that means that if a metal is formed, we usually form it in the form of a liquid. So if he says what is observed at the cathode, what I see at the cathode is actually a gray metal. Remember that any metal other than copper and gold, all other metals are silvery in color. So this is silvery metal or silvery gray metal is formed. If he says which substance is formed at the cathode, of course it is sodium. Okay, so the result is when I do electrolysis of molten sodium chloride, I get chlorine at the anode and sodium at the cathode. You will always get the non-metal at the anode and the metal at the cathode. Let's try another one. Let us do electrolysis of molten lead to bromide. Now, the first thing you're going to do is, what ions do we have? Lead is a positive ion. How many positives? The number of positives is the same as the valency. So when I tell you lead 2, that means that the valency of lead is 2, and that means my positive ion is Pb2+. That's my positive ion. Now it is lead bromide. Bromide is actually bromine with a negative on it. Now how many negatives? If you remember, bromine is in group 7. That means its valency is 1, so it has only 1 negative. Do we understand this? So that is your first job, to find out which ions I have. If I'm doing electrolysis of molten lead 2 bromide, the ions I have are lead 2+ and Br-. Now, which one goes to the anode and what does it do there? Which one goes to the cathode and what does it do there? We said the one that goes to the anode is the negative, because the anode is the positive electrode that is connected to the positive end of the battery. So the negative ion goes to the positive. Now the negative ion goes to the positive and does what? And loses electrons. So the negative ion gives electrons. Now when it gives electrons, it changes into atoms, but bromine is diatomic, so it becomes Br2. So I need to balance the equation. So if he says name the substance formed at the anode, bromine. But what is observed at the anode? If you remember, bromine, this is molten, so this is a liquid at a very high temperature. Bromine is usually a liquid at room temperature, but this is a molten lead bromide. That means I heated it to very high temperature, so the bromine is in the form of reddish brown fumes. Are we following? Okay, lead 2 plus. Now, the 2 plus goes to the negative. What does it do at the negative? It takes electrons. Now, if I have 2 plus, that means I need 2 negatives in order to be balanced. So, if 2 positives and 2 negatives on this side, that means the net is 0. On the other side, it is also 0. So, this is the equation that happens. So, name the substance that is formed at the cathode, lead. What is observed at the cathode? It's a silvery gray metal. Okay, so far we've been doing molten. What if we do an aqueous solution and we're using inert electrodes? Remember, I forgot to tell you that in all of these so far, what electrodes are we using? We're using graphite electrodes. So if he says name a substance, it is graphite. What if he says name an element? Which element is in graphite? It's carbon. So if we say the electrode is made of which substance? It's made of graphite. Made of which element? Carbon. Now, usually it is graphite. If he says use a metal and we want it to be inert, the metal that we usually use is platinum, because platinum conducts electricity since it's a metal, but it is very less reactive than all the other metals, so it is an inert electrode. Now, what is the difference between platinum and graphite? We said which one is better? Graphite, since it is cheaper. You should know that platinum is expensive. So, let's say we're doing electrolysis of a solution of HCl, hydrochloric acid. Now, there is a difference in solution. Are we talking about a concentrated solution or are we talking about a dilute solution? So if he says I'm doing electrolysis of concentrated HCl, first of all, what does concentrated mean? He said concentrated solution is one that has a very small amount of water, a lot of HCl, then it's concentrated. So I have a lot of HCl in my beaker, I dissolved it in only a very small amount of water, that is a concentrated solution of HCl. My first question would be, what ions do we have? So, the ions that we have are the H plus and the Cl minus. But this is something that also contains water, and you have to remember that when you have water, electricity passing through it, the water ionizes to form what? The water ionizes to form H plus and OH minus. So if I have a solution, remember that I don't have just the ions of the substance, I have the ions of the substance plus the ions from the water. So these are the ions that I have in my solution. Now, which ones will go to the positive? Remember that all the negative ions will go to the positive electrode, but only one type of ion will react. So if we say which ions go to the positive, the chloride ions go to the positive, the hydroxide ions go to the positive, but only one of them can react. Now, here we have a choice. There are rules for choices of different kinds. What am I choosing between here? I'm choosing between chloride and hydroxide. Which one is going to react when we're choosing between chloride and hydroxide? The one present in higher amount is the one that will react. And this applies just to chloride and hydroxide. So chloride and hydroxide, which do I have more of it? Do I have more of chloride or do I have more of hydroxide? Well, this is, we said, this is a concentrated solution. A concentrated solution has a lot of the chloride, very little water. That means I have very little of the hydroxide. That means it is the chloride that will react. And we said when the chloride goes to the positive, what does it do? It loses electrons and becomes atoms, which should be diatomic to form a chlorine molecule, and then we balance. Understand this? So what is formed at the anode? It is chlorine gas. What is observed? It is bubbles of green gas. Let's go to the cathode. Now, I don't have any choice. The only positive ions I have are H plus, and H plus will take up electrons and become H2. So it will form hydrogen gas. So what will be observed? If hydrogen gas is being formed, then I will see what? I will see bubbles of colorless gas. So that is my observation. Do we understand this so far? Okay, let's try something else. What are we doing here? We're doing electrolysis of concentrated sodium chloride. Again, the first job you have to do is find out which ions. do we have? I will have the sodium plus and the Cl minus, and I will have the H plus and the OH minus from the water. So these are the ions that I have. Which ones go to the anode? Chloride and hydroxide. Which one of them is going to react? Well, what do I have? I have concentrated solution. That means I have more chloride. So it is the chloride that will be formed. Okay? Chloride will give electrons, become chlorine gas. So I will see bubbles of green gas. And this is actually the method of making chlorine gas. So to manufacture chlorine gas, that means to prepare chlorine gas on a large scale, they do electrolysis of concentrated sodium chloride solution. On the other end, I have a choice between two things. Now, let's look at this. At the negative electrode, both the Na plus and the H plus will go to the negative electrode, but only one of them can react. The question would be which one? Now, the one, if I have a choice between a metal ion and H plus, it is always a reactive metal. Let's say a reactive metal. It is always the H plus that will react, because I'll tell you why. The Na is sodium, that is a very reactive metal that has only one electron in its outer shell. When it forms Na plus, that means it has lost that one electron that's standing alone in the outer shell. It really doesn't want to take it back. So if I have a choice of anyone else taking the electron, it is the other ion that will take the electron. Remember when we were doing molten sodium chloride, I didn't have a choice. I only had Na plus and there is no other choice, so the Na plus was forced to take the electron. But now I have a choice. If I have a choice between Na plus and something else, it is that other thing that will take in electrons, because actually the sodium ion is happy as it is. It has a full outer shell. It doesn't want to take back that extra electron that stands in the outer shell. Okay, so what is formed here is hydrogen gas. So I see bubbles of colorless gas. Now, if the H plus reacted at the negative, the Cl minus reacted at the positive, what is left in the solution? I'm left with the Na plus and the OH minus. Na plus and OH minus is actually sodium hydroxide. So remember that when I do electrolysis of concentrated sodium chloride, I have three products. What are my three products? Chlorine at the anode, hydrogen at the cathode, and sodium hydroxide in solution. Do we understand that? Let's try another one. Now here we're doing electrolysis of dilute sodium chloride. What is dilute solution? Dilute solution means I put just a little bit of sodium chloride in a lot of water. That's dilute. Now, the first question I ask myself, which ions do we have? Well, we still have the same ions we were talking about previously. We have the sodium ions and the chloride ions, and we have the H plus and OH minus from the water. Good. Now, which one is going to react at the anode? Remember that we said we have a choice between chloride and hydroxide. Now, which one is going to react? We said the one, when I'm choosing between chloride and hydroxide, the one that is present in larger amounts is the one that will react. Now here, when we're doing a dilute solution, which one is present in larger amounts? The hydroxide. So it is the hydroxide that will react. Now you have to remember, when hydroxide reacts, what does it do? It loses electrons, of course, and it changes into what? It changes into oxygen and water. Okay? So first of all, when hydroxide ions react at the anode, they form oxygen, water, and electrons. And then you need to balance. Can you balance this? So as we balance, we'll find that we have 4 OH minus. That means I have 4 oxygens, and 4 hydrogens. So on the other end, I have to put 2 in front of the water. And that makes 4 hydrogens and a total of 4 oxygens. But then if I put 4 in front of the OH minus, that means I have 4 electrons, or 4 negative charges. So I need to put 4 electrons after the arrow. Okay? So what is formed at the anode? We don't say water is formed, because water is present anyway from the beginning. So what I'm forming here is the oxygen gas. So if I say name the product at the anode, it's the oxygen gas. And that means, what will I see? What is observed? The observation is bubbles of colorless gas. Okay, let's go to the cathode. Again, at the cathode, I have a choice between Na plus and H plus. And we said, if there is a choice between Na plus and H plus, which one reacts? Always the H plus, not the Na plus. Remember that the Na plus does not want to take electrons unless if there is no other choice. So that means I'm going to form hydrogen at the cathode, and that means I'm going to see bubbles of colorless gas. Are we following? Okay, let's try again. Electrolysis of aqueous copper sulfate. And I'm using graphite electrodes. Again, reminding you, I'm using graphite electrodes in all of these electrolysis that we've been talking about. Okay, first question. What ions do we have? Okay, copper. Copper has what kind of charge? This is copper 2 sulfate. So it is copper 2 plus, and the sulfate is SO4 2 minus. And I have the H plus and the H minus from the water. Now, what will happen at the positive? What will happen at the anode? Which ones go to the anode? The sulfate ions and the hydroxide ions. So I have a choice. Which one of these will react? Always remember, sulfate will never react in our examples of electrolysis. So it is the hydroxide ion that reacts. So remind me again, if the hydroxide reacts at the electrode, what does it give? Remember what we said? It gives oxygen, water, electrons, and the same balancing of the equation. So what will I form? The name of the compound or of the substance formed at the anode is oxygen. The observation is bubbles of colorless gas. Let's go to the other end. At the cathode, which ions go to the cathode? The positive ions, copper 2 plus and H plus. Now, I have a choice between copper 2 plus and H plus. Which one reacts? Remember, when we said I have a choice between Na plus and H plus, we said the Na plus doesn't want to react. So it is the H plus that took the electrons. But here, the copper is regarded as a less reactive metal. The less reactive metal, it is less reactive than the H plus. So it is the copper 2 plus that will take the electrons. So remember, if I have a choice between copper ions and hydrogen ions, it is the copper ions that will take electrons and become copper. The copper has 2 positives, so it will need 2 electrons in order to be neutral. And copper is what color? Remember that copper is a reddish brown metal or a red metal. So I form a red metal. Remember that we said metals in general are silvery gray except copper, which is red or reddish brown, and gold, which is yellow. Okay, let's do electrolysis of dilute sulfuric acid. Again, what ions do we have? We have the H plus and the SO4 2 minus from the sulfuric, and we have H plus and OH minus from the water. Which one goes to the positive? The sulfate and the hydroxide. Now, I have a choice between sulfate and hydroxide. Which one is going to react? Do you remember? We said if I have a choice between sulfate and hydroxide, it is the hydroxide that reacts. When hydroxide reacts, it gives what? It gives oxygen plus water plus electron and balance. And that means what is observed? Bubbles of colorless gas. On the other end, I don't have a choice. I have only H plus, so the H plus will take up electrons and become hydrogen molecule. Bubbles of colorless gas are formed. Do we understand this? Okay, let's try some questions. So this is a possible question. Magnesium can be obtained by the electrolysis of magnesium chloride. Solid magnesium chloride is obtained from seawater. The magnesium chloride is melted and then electrolyzed. So they're doing electrolysis of molten magnesium chloride. The positive electrode is made of graphite and the negative electrode is made of steel. So that's another metal. Magnesium forms at the negative electrode. Chlorine forms at the positive electrode. And his first question is, explain why the magnesium chloride has to be melted before it can be electrolyzed. Remember that we said in order to do electrolysis, the solution should, or the substance should be something that conducts electricity. Magnesium chloride is an ionic compound. It conducts electricity only when what? Only when molten or in solution. Why is that? Remember, because when molten or in solution, the ions are free to move. He has 2 marks. That is because he's saying explain why magnesium chloride has to be melted. So you have to tell me that the ions are free to move when it is molten, but they are not free to move when it is solid, or that the solid magnesium chloride, the ions are not free to move. Now he's saying write an ionic half equation to represent the formation of magnesium at the negative electrode. We said magnesium will form what kind of ions? This is a metal, it forms positive ions. How many positives? Well, you look at the periodic table, you find that magnesium is in group 2, so its valency is 2, so it's magnesium 2+. We said the positive ions go to the negative to do what? To gain electrons. How many electrons does it need to gain? Well, if it has 2+, it has to gain 2 electrons in order to form magnesium. This equation is what we call ionic half equation. So just why steel is not used for the positive electrode. Now, why wouldn't it be a good idea to put steel, which is a metal? I will tell you that steel is actually iron plus carbon. So it is iron plus carbon. That is what we call steel. So it's a metal. So why don't we use it as a positive electrode? Because if I put it as a positive electrode and he's saying that chlorine is formed at the positive electrode, then the iron will react with the chlorine. We don't want reactions to happen. Okay, this is another possible question that you might have. This apparatus is called a Hoffman Voltammeter. It is used to collect the gases produced when an electric current passes through a solution of dilute sulfuric acid. So here he's doing electrolysis of what? A solution of sulfuric acid. Name the process that takes place in the Hoffman Voltammeter. So when he puts the dilute sulfuric acid and he connects one electrode to the positive end of a battery and another to the negative end of the battery, and this breaks down, we said this process is called electrolysis. State why zinc should not be used for the electrodes. He said the electrodes are made, he doesn't actually say the electrode is made of what, but he's saying it shouldn't be made of zinc, of course, because zinc would react with the dilute sulfuric acid that I'm trying to do an electrolysis of. And that is why we usually use inert electrodes, which are usually graphite or a platinum electrode that doesn't react. Write an ionic half equation to represent the reaction that produces hydrogen at the negative electrode. Remember that if we have an acid, that means I have H+. Dilute sulfuric acid, for example, will have H+ and sulfate ions, and the H+ and hydroxide ions from the water. So which one will happen at the negative? We said at the negative, the H+, I don't have any choice actually. So the H+ will take up electrons and become hydrogen, and that means that that is my ionic half equation. Now write the ionic half equation at the positive. Which one is going to go to the positive? Now I have a choice between sulfate and hydroxide. Both of them will go to the positive, but which one reacts? The sulfate never reacts. It is the hydroxide that reacts. So this is my ionic half equation. Do we understand this? Okay, let's try another possible question that you could have. This apparatus can be used to investigate electrolysis. Name the particles that move through the wire. We said what moves through the wire? It's the electrons. Now, the electrodes are made of platinum, which is an inert metal. State what is meant by the term inert. Do you remember we said what does inert mean? It means something that's not reactive. So when I put graphite or platinum, they are inert. That means they do not react with the solution that I'm trying to do electrolysis of. Explain why the electrolytic cell containing PbBr2 needs to be heated before electrolysis. Remember that lead bromide is an ionic substance. The lead is in group 4. If you look at lead, it is in group 4, but it's at the bottom of group 4. Group 4 is supposed to be non-metals, but at the bottom of group 4, lead is a metal. So this is metal and non-metal. So lead bromide is actually an ionic compound. Why do we need to heat it before electrolysis? We said the ionic compound needs to be molten so that the ions can move freely. Okay, this is another possible question that you could have, and then of course after that you will go and do the questions in your chapterized questions. But let's try this. When sodium chloride aqueous is electrolyzed, two gases form at the positive electrode and one gas forms at the negative electrode. The formula of the species are these ions. What gases do you expect to form at the positive? So which of these will go to the positive? The negative ions. What negative ions do we have? Well, we have Cl- and OH-. And remember that we said, if I have a choice between Cl- and OH-, which one reacts? The one that is present in higher amount. So that means each of them could react. Now, if the chloride ions react, that will form chlorine gas. If the hydroxide ions react, that will form oxygen gas. So these are the two possible gases that could form at the positive. Now, which gas would form at the negative? Well, which one goes to the negative? The one that goes to the negative is the sodium and the H+ ions. But which one will actually react? He said, if I have a choice between Na+ and H+, it is the H+ that will react. So that will form hydrogen gas. Give ionic half equations to show the formation of each gas. So if we have chloride ions reacting, this is the half equation that you have. Hydroxide ions reacting, this is the half equation. Hydrogen ions reacting, this is the half equation. So you need to sit down and study all of this. Study this hard and try the questions in your chapterized questions, in your PDF version of the chapterized questions, and then take a look at the next video in order to see the correct answers to these questions. Okay,